When I was a child, my parents used to say that I was born with spurs in my feet. I didn't understand what that meant. I just couldn't sit still. I was always moving around from place to place. Sometimes it was to just find a better place to be. And some other time it was just to find better answers. Only later in life did I understand that that statement was so much more metaphorical than literal. That was the very definition of innovation, not to accept status quo and everything. Try to find out about things, about the universe. So today I'm going to talk about the process of innovation. The why, when, and how of innovation. If we have to get away from accidental or random innovation or jugaad, as we keep hearing, we need to understand the process that drives innovation. We need to understand and put a structure around making sure that hard work and ideas come together more often, and success and the probability of success increases. We don't depend on luck anymore. I'm deeply influenced by the greatest innovator of all times, Leonardo da Vinci. I'm going to take 3 of his concepts to build my thesis today. The first one is a very interesting Italian word called arte scienza. What does that mean? It is the art of balancing art and science to understand the universe. The second word is conexión. Conexión means that everything in this universe is connected with each other and communicating with each other. And the third one is curiosita. It's the curiosity to find these connections. So I'm in August company today, and I'm going to use these 3 concepts and grade 8 mathematics to outline the process of innovation. I'm sure you're going to cringe on the 5 slides of mathematics, but trust me, after that, I'm going to let your imaginations go wild. So the first concept I'm going to talk about is about innovation. I did a lot of studies and found that every study talks about the fact that innovation doesn't happen in isolation. It is always linked with something that happened before. It is always linked with some invention, some discovery, some intervention that happened before, and some change C. So you can write that. If Y was innovation, we can say yn plus 1, which is the next innovation, is a function of something that happened in the past, yn plus C. I think we can depict that in mathematics. Now, if we write it over a long series, we realize that we are always trying to find the why. Why did something happen? Why did this phenomena happen? Why did that event happen? We are always trying to find the why and find patterns of data. And that why is the past. That is what we are trying to link. And once we have found this pattern, we ask the question, what next? And when we find that our what next answers are coming true, we know we have found a pattern. This curiosity of why and what next is the innovation chain. And we define what this innovation chain is. And each one of us have our own method of finding this chain. Now I'm going to introduce the second equation. So innovation is a complex construct. It is not just the hard work, but it is also an idea. Idea and hard work have to come together. Idea is an abstract term. Hard work is visible and it is real. So we need to depict it mathematically. So we call it a complex number, A plus IB. A is the coefficient of the real number, which is our real action, our work that we do. And IB, which is B, is the coefficient of the imaginary number, the idea, the concept. Right? You can't explain that. And whenever mathematicians had to depict something complex, they put an I there. And I was the square root of -1, if you remember your grade 8 mathematics. So now we have got 2 variables and 1 equation and lots of iterations. So lots of answers are possible, right? Lots of places of A and B, the equation will converge, and lots of places it won't converge. So let's see what that would mean. So we are plotting the real action that we do and the imaginary ideas or the ideas that we have got, and the z-axis is time, and let's ignore that for a moment. It is just a plotting of your mind and your matter. 1969, a French mathematician called Mandelbrot who was solving a totally different problem at that time. He was trying to find the circumference of Britain. He stumbled upon this equation, and he plotted it on an IBM mainframe computer at that time. He could only do 1,000 iterations of this, plotted every possible combinations of A and B, and he found that this shape, and that shape is called the Mandelbrot, outlined how these two equations converge and where the convergence happens. Now, this gave birth to a whole field of study called fractals. And I'm going to look at it in very different ways going forward. So now computers can do billions of iterations and plot billions of values of A and B and keep going down and keep zooming in. So we took a computer algorithm, plotted it over days together, and the visualization is what you're seeing on the screen right now. The colors on that graph, on that chart, shows the time it took for the equation to converge. So when you look at innovation, there is a lot of things going on. And at the end of this billions of iterations, we come back to where we started. There is something primordial about it. That you start, go billions of iterations later, and you're back again to where you started. Right? And that is the equation and the visualization of the innovation equation. So anything that is a network, we showed how innovation is a network. Anything that is a network has fractal properties. Okay? And that is what we are trying to use for today's equation. So what's the definition of innovation and discovery and invention? An innovation can be both a discovery, it could also be an invention. Discovery is finding patterns that already exist in nature. Things are happening. Events are happening. Random events are happening. And we discover these patterns. We discover elements. We discover gases. We discover fire. We discover things that already existed. And we try to predict what next. And when we don't like what next, when we want to change what is going to happen, we invent something. We say, no, I don't like it. I don't like my status quo today. I want to change it. And therefore, you invent something to change what next. That is invention. And all of these follow a fractal pattern. So let's take a look at how discoveries are done. So there are random events happening. You know, somebody is trying to do a flint and finding fire. After a lot of movements of his thing, he creates fire. They're looking at gases and they discover elements. They discover all kinds of similar gases and similar elements, and a field of study is born. Chemistry is born. The same events and the same study with some small change C can create a whole field of study or a whole new field of study. Let's take the same elements and you can find quantum computing and quantum physics. They are all looking at the same elements of atoms, right? So that is how discoveries and related discoveries are done, right? When you look at invention, I mentioned that you are essentially trying to solve a problem that is there. And you look at existing discoveries, you look at existing inventions, and you say, can I combine them to solve this problem? And you come up with a new innovative way, right? That also is always related to some invention, some discovery that happened in the past. So you can again write it in the same way. Now, innovators, take Elon Musk, doesn't solve all the problems themselves. They take their idea and they split it into lots of ideas. So you take this y-axis and you say, you know what, I don't want to deal with it all myself. I'm going to farm it out to lots of people. You collaborate. And they let others build on their ideas. They also are able to bring together ideas from various fields into their domains. And this ability to manage innovation, this ability to split your ideas, to bring ideas together, using energies of the whole universe to help you validate your ideas, is what innovation is all about. It's all how this equation is going to work. You bring in the energies, you bring in the ideas of lots of people and make it work. And for innovation to succeed, you need to open source your ideas. You cannot be sitting on it and holding on to your ideas. You know, you've got to let the world know what you're doing. You need to combine your ideas. You need to bring it together. You need to bring paradigms shamelessly from other ideas, from adjacent countries, from adjacent geographies, from adjacent fields of study. You need to split your ideas. And you need to use the energy and the actions of the universe to help you get there. And create something new that will benefit society. That is what innovation is all about, working to solve a problem that is going to benefit society in the long haul. There was a time when innovation used to happen in closed rooms, used to happen in secret. We didn't want the information to go out, but those days have changed. There is nothing that happens in this universe today that is not validated by lots of people, different schools of thought, different people coming together, contributing to make innovation work. And that is all got to do with combining equations of lots of people into one gigantic waveform that is going to bring about success. The probability of success goes up if we do it that way. The other thing that we need to look at is what zone of this fractal space are you working on? Are you working on the big boring area where you've got open-ended effort? You don't know when the energy and action is going to collide. Or you're working in the little boring area, which is bounded efforts. You know, when you look at work that is happening in the industry, they look at this little boring area. They have got bounded effort. They know that they have to succeed in a short period of time. And then innovation is happening at the edges of these two. When you can go deep down, we saw in the video how you could go zoom in and you found that convergence is happening. A lot of ideas are happening in the edges. That is the interesting part. The last concept that I want you to think about when you look at this equation of innovation is the C, yn+1 for C. The C, I said, was change, but it is also constraints. You need to understand the constraints of innovation. You can't pluck an idea from one side and bring it to the other side and make it work without understanding the constraints that you're putting it under in the new geography, in the new paradigm. And each paradigm has its own set of constraints. And then finally, certain geographies don't allow that cost to also look at, to impact what you're going to achieve. So that, my friends, is the whole equation and the mathematics of innovation. So in summary, we have seen how innovation follows a fractal pattern. You can engineer your probability of success by knowing which zone you're operating, by making sure that you're spreading the energy and action of lots of people to achieve success. Thank you.